Hi campers! My name is Izzy Newsom and I work in Paul Dayton's lab at UNC. My research focuses on improving and developing contrast-enhanced ultrasound imaging for cancer detection and diagnosis. On a given day in the lab, I'm writing code for MATLAB, making contrast agents or imaging phantoms, or imaging animal or human subjects. In undergrad, I majored in physics, minored in mathematics, and worked in a biophysics research lab at Clarkson University in Potsdam, New York. I also participated in a nuclear physics summer research program at Duke University. During my summer at Duke, I took a tour of UNC and I learned about biomedical engineering for the first time. I instantly knew this was the perfect field for me because it combines all the multidisciplinary sciences that I love in a way that can directly impact and benefit the world through healthcare. My undergrad experience really helped prepare me for this career by giving me a super strong fundamental knowledge base in physics and math and chemistry that I can draw on every single day in BME. Because this is such a diverse, multidisciplinary field, truly any STEM education can contribute to helping you become a successful biomedical engineer.
Hey everyone, my name is Travis McKay. I work in Dr. Michael Danielle's lab at NC State, the Biointerface Lab, and my research focuses on developing next-generation multi-analyte biosensors and understanding the underlying chemistry behind regenerating sensing surfaces. On a typical day at work, I'm either preparing for experiments, programming and developing the instrumentation used for my sensors, analyzing data, or reading papers to stay updated about the field. I studied chemical engineering at the University of Maryland, Baltimore County for my undergraduate degree, and I first became interested in biomedical engineering during a summer research experience where we were developing a passive biosensor that analyzed human sweat. The driving force was created by inducing an osmotic pressure gradient, and this involved a lot of chemical engineering with the equations, assumptions, design, and composition of all the materials we were using in the sensor. I thought it was fascinating how we could learn about our health condition from certain analytes in our sweat, such as cortisol, which can be an indicator for our stress levels, glucose, which can be important to monitor if you have diabetes, lactic acid to measure your physical exertion if you're an athlete, and the list really just goes on and on. So I kind of realized that there were more ways than sweat to extract important information from the body, and that's sort of the route I'm taking with biomedical engineering. I want to work on the tools that can be used to interface with our bodies that can provide crucial diagnostic information about our health. What helped me the most during my undergraduate studies that prepared me for my career in biomedical engineering is the numerous research opportunities I was able to partake in. After every experience, I was able to reflect on what I liked and what I didn't like in science, and I eventually was led to a field and a specific area of research that was married to my interests. So that's why I got here today. I'm currently finishing up my first year as a PhD student. If you have any questions for me, I'd love to talk more, but I hope you're enjoying this year's program. Thanks for listening. Go Pack.
Hi everybody, I'm Noah. I just finished my second year of my PhD. I currently work under Dr. Zhao Ganghu and Dr. Helen Huang at UNC and NC State respectively. I'm co-advised. I currently work on trying to improve the interface of assistive and rehabilitative devices with individuals with mobility impairment and such as stroke survivors or amputees, essentially trying to have these devices do what the user actually wants it to do more effectively. And so on a typical day at work, I'll usually either be working in a lab trying to set up some equipment or processing or analyzing data in MATLAB, or like I am right now, reading literature and writing a manuscript for publication. And so in my undergrad, I studied biology at UC Santa Barbara, and I luckily had a flexible curriculum that allowed me to take neuroscience or mechanical and electrical engineering courses to help me prepare for the interdisciplinary field I'm in now. One of the biggest things that also helped was getting involved in research early on, which really exposed me to a lab dynamic early so I could know what I wanted for grad school as well. And if it's allowed, you're welcome to share my contact info if anybody has any follow-up questions. Yeah, hope you enjoy the program.
Hey Biomed Engineer campers, my name is Justin Huckabee and I'm a grad student here at UNC Chapel Hill studying biomedical engineering. So I wanted to talk to you guys a little bit about what I do real quick in the field of biomed engineering. So it's a really broad field. I work in Sam Lai's lab, who's technically in the School of Pharmacy. So I make different drug molecules and then I subsequently test them on cells like I'm looking at under the microscope here. I also do cell therapies which use cells as drugs. So there's a lot you can do on the pharmaceutical side of biomed engineering. I did my undergraduate in biomed engineering, so when I was your age, I was really interested in science, particularly biology, chemistry, which I use a lot of today. Same for mathematics. So I pursued biomed engineering with a minor in chemistry in undergrad, and I'm now pursuing a PhD in biomed engineering, doing more pharmaceutical science research. And the field is so broad, some other folks you may hear from, they may do larger scale whole human, like rehab engineering, robotics type things in biomed engineering. So you really kind of do anything from electrical, chemical, mechanical, or a combination of all of those. So I hope you guys have a good week at the virtual BME summer camp. Thanks for watching.
Hi, my name is Mara Brable and I am from a small town in south central Pennsylvania called Boiling Springs. I went to the University of Notre Dame for my undergrad and I majored in chemical engineering. I did undergraduate research to develop a platform for testing peanut allergies and possibly creating a new therapeutic to actually cure peanut allergies. I am currently a second-year PhD student in the Joint Department of Biomedical Engineering between UNC Chapel Hill and NC State, but I'm based at NC State. I engineer therapies to activate the immune system and enable the body to fight its own cancer. Currently, I'm working on how to synergize cryoablation and immunotherapies.
Campers, my name is Miranda. I do research for Dr. Derek Camper at NC State. I work in the rehabilitation engineering track and I look at hand biomechanics of children with cerebral palsy. I do a lot of different things in my research. I program both in LabVIEW to control different sensors and machinery during experiments and MATLAB to analyze all the different data and biosignals I get back from experiments. I also do experiments with people. So people come in and do different things with their hands and I measure signals from their muscles. I also use technologies like electromyography and ultrasound to analyze their muscles. When I'm done with an experiment, I'll do a lot of writing, either to submit an abstract for a conference or to write up a paper on my results and submit that to a journal. I got my undergraduate degree in biomedical engineering from Georgia Tech. I started with a pre-health track because I had planned on going to veterinary school after my undergraduate degree. I actually learned about biomedical engineering from a pre-health day at Georgia Tech that talked a lot about the major and at the time proposed it as a good degree for people pursuing a health degree. I actually ended up finding that it probably wasn't that compatible, but I ended up enjoying biomedical engineering more than pursuing a degree in veterinary medicine, so I ended up staying with that major and going on to grad school. I learned a lot of different things in my undergrad. I learned a lot of human physiology as well as cell biology, which is very helpful. Also chemistry, lots of physics, lots of math and calculus. Other things that maybe aren't as typical biomedical engineering, at least when you first think of it, I learned how to program in both MATLAB and how to use CAD software, which are super important now for when I'm analyzing data, or I often make my own rigs to measure different things, and having CAD software, it's great to either be able to 3D print things to use or send them to machinists to have them professionally machined. I also really learned how to do good research in health fields from my undergraduate degree, so now when I have to learn about a different medical technique or a condition, it's pretty easy for me to go online, read a bunch of papers, and understand them pretty well from my background, and to be able to be competent in that field of medicine pretty quickly. I also learned how to figure things out and have critical thinking, which is really important because it's going to be impossible to be perfect at chemical, electrical, and mechanical engineering, which are all kind of parts of biomedical engineering. So being able to have the basics and the scientific background, but also be able to teach yourself different things and think on your feet and adapt, I think is super important in biomedical engineering because it is that fusion of all different types of medicine and all different types of engineering. So that's really helped me in graduate school because there have been lots of things I've had to teach myself and learn. And I think my undergraduate degree really prepared me for that. So that's been my journey in biomedical engineering. I hope you will consider a career or studying biomedical engineering in college. I've definitely enjoyed it. Goodbye.
Hi campers, my name is Sienna. I just finished my first year as a graduate student in biomedical engineering. I research in Dr. David Zaharos lab, aka the Z lab, at NC State. We focus on immunotherapies and immunoengineering to fight cancer. This approach uses the body's own immune system to eliminate disease. Cancer happens when the body's immune system can no longer keep damaged cells from proliferating. So, if we re-educate the immune system and make it work again to catch and kill the cancer cells, we believe we can eliminate all cancerous cells, no matter where they are in the body. In terms of a typical day spent in lab, right now, especially in quarantine, I don't have a typical day. I could spend time in lab making gels, culturing cells, or treating animals that have tumors. Or I'd be preparing for experiments and reading lots and lots of papers. I didn't graduate with an undergraduate degree in biomedical engineering. I majored in chemical engineering at the University of Notre Dame in South Bend, Indiana. I learned a lot about chemistry, and I really enjoyed it. I performed 2 years of undergraduate research, and I spent 2 summers in labs, one in a chemical engineering lab and the other in an immunology lab. When I first entered college, I was originally interested in joining the medical profession because I wanted to help people recover from illnesses. However, I also realized that I enjoyed making things and verifying that they worked. And that's when I realized I could do both. Biomedical engineering perfectly aligned my 2 interests. I applied for graduate programs in the fall of my senior year, specifically to study immunotherapies. In the first year of graduate studies, I couldn't decide on labs, so I rotated between 3. I studied immunology in the context of ultrasound, small molecule delivery, and protein delivery in these 3 labs respectively. Even within the BME subset of immunology, the field is really diverse, and overall, BME is a very broad field. The breadth of BME is something to consider when entering undergrad. I'm personally glad that I chose to major in chemical engineering. It helped me to develop a solid foundation in chemistry, which is something I can apply to BME. Also, as a chemical engineer, I will admit, I was more marketable post-graduation than most BME majors are, should I have wanted to enter the workforce instead of pursuing graduate school. The same goes for mechanical engineering and electrical engineering. These engineering specialties can take their skill set and apply it to biology. And this is something I wish people had told me when I applied to BME undergraduate programs. Notre Dame was actually the only school that I applied to that didn't have BME, so I felt like I was taking a risk when, in the end, it was probably less risky. So overall, you can get into BME through a lot of disciplines in college. I'm personally glad that I chose the chemical engineering route as it helped prepare me to research immunotherapies. Don't stress about majors in college. You will graduate with a major, and if you want to enter BME after undergraduate, you can. You will have to work hard for what you want, but it's totally worth it. And with that, I hope you have an awesome week.
Hi, everybody. Welcome to the Joint Department of Biomedical Engineering online summer camp. Hope you're having a wonderful day and learning a lot about all the different types of engineering we're doing. So my name is Ricky, and when I left high school, I was really interested in physics. like projectile motion, dynamics, forces and moments, all that kind of stuff. So when I got to college, I started off as a physics major. But after a couple classes in calculus and things like that, I just wasn't doing so well. So I ended up changing majors, and I switched to health and exercise science. So I continued health and exercise science, really liked that. And I also got a minor in biomedical sciences. And then towards the end of my time in undergrad, I was finding out about this field called biomechanics, which is the analysis of human movement. So it kind of mixes mechanical engineering and movement science. So I ended up sticking around at my undergrad university, which is Colorado State University, and I stuck around for a master's, and I worked with a professor there who did human biomechanics. So I got the master's in that, learned a lot more about how muscles and tendons drive human motion and how human motion is affected by various diseases. And I ended up getting a job at a children's hospital. I was really lucky. I joined a clinical gait lab or movement analysis lab at the local children's hospital out there. And there we mainly performed movement analyses on children with movement disabilities, so cerebral palsy, spina bifida, all that kind of stuff. And we worked with a team of physical therapists, surgeons, and rehab docs and engineers on figuring out what the best therapies, surgeries, treatments, any of the above, whatever was best for each kid, because each kid had a slightly different walking ability. So while I was there, I was a research assistant. I ran a couple of research projects. One of them was on plantar pressures in children with spina bifida. So we had all these movement analyses for kids with spina bifida, and all we really had was a bunch of videotapes and these plantar pressures, and we were interested in using the data and the information from these plantar pressures on how we could track these kids longitudinally, because these analyses could be done very cheaply and also get a lot of cheaply and quickly and get a lot of qualitative information on their walking patterns. So that's one of the projects I worked on. Others had to do with quantifying movement in other ways, using like accelerometers and comparing that to what's called 3D motion capture. So here on the left, you can see a kid with some type of movement disability. And he's dressed up in all these 3D reflective markers. And using those, we can record the movements of his legs, his feet, his lower legs, his thighs, his hips, his torso. And from that, we can backwards calculate, using inverse dynamics, the torques and forces passing through each joint, and then also figure out how much power is being generated or absorbed at each joint. So this kind of really brought me back towards my physics days of high school. And now I kind of combines the human movement science and physics. So it kind of worked out for me, luckily. But you can see that also for this kid, and for lots of kids, this technology works. So you can't see because my screen's in the way. But we're looking at a kid's movement patterns in the black and the gray line, compared to the gray bar or the gray area, which is the normal range of movement. So you can see that after a certain type of surgery, which is a selective dorsal rhizotomy, or SDR in this example, we can change the movement patterns of these kids and help them walk a little bit more normally, which will help them to not only be more independent, but also move and play with their friends and walk around theme parks and just be a normal kid and not have to worry about their disease. So that's kind of the goal of what I was doing at the Children's Hospital. And then I decided I really liked this area of research and work, so I wanted to continue it. And so I figured it was time to go get my PhD. So that's why I came to UNC and NC State. And I've just finished my first year of the PhD program. And I'm working with Jason Franz at UNC in the Applied Biomechanics Lab. And some of the work that I've been doing over there has been using musculoskeletal models, kind of like this one. So we can take all that movement data that we record inside a lab, So you can see all these dots are markers that we place on the body, and then we kind of fit them to a simplified model of the human body. We're missing some arms there, obviously. But we have all the bones, we have all the muscles in blue there, and we can kind of simulate how much force these muscles and tendons need to produce to cause this person to walk. So we can backwards calculate all that. And we can also estimate, one of the things that I'm working on is estimating the metabolic cost of these muscles. So how much energy does it take for you to walk? Right now, one of my projects that I'm working on is estimating the metabolic cost of walking when you push off the ground with more and less force. And this is applicable to people with different types of gait difficulty, but also primarily older adults, because as they age, we tend to push off the ground with less force. And that is usually due to a decrease in calf or ankle power. And what ends up happening is you end up absorbing or using more energy and using more force and using more energy and applying more force at your hip on the opposite side to kind of pull yourself forward rather than push yourself forward with that ankle behind you. And so we're trying to figure out what's causing the increased cost or energy cost of walking in older adults, and what we can do about it to help keep people walking as long as they're alive and as long as they can stay healthy. So that is what I'm doing here in the Joint Department of Biomedical Engineering at UNC and NC State. And thank you for joining us today, and I hope you learn a lot and ask a lot of questions, and realize that there's not just one way to go about getting into biomedical engineering. There's a lot of different paths. Everybody takes a different way, and you just got to figure out what you like to do and what your way of doing it is if you want to get into this field, and just stay motivated and optimistic for the future. Thanks a lot, and take care.
Hello, my name is Zach, and I'm a third-year graduate student in the NC State-UNC Joint Department of Biomedical Engineering. My research focus is on tissue engineering, or trying to build new tissues and organs, specifically for the knee. I work with building new types of 3D printers and with gelatin, or as you may know it, Jello. My interest in research started when I was in middle school, though back then I wanted to pursue marine biology, and specifically I wanted to do research on sea turtles. As I got older, I learned more about genetic engineering and later biomedical engineering, and my interest shifted. I still love sea turtles, but I decided that biomedical engineering was where I could do the most good. I started my training as a researcher when I got to college, and quickly learned the #1 rule. You will have to repeat experiments multiple times. The in research is because you have to repeat your search. This may be because something went wrong or the experiment failed, but each of these times teaches you something new that you can then change for your next attempt. My favorite part of research is the collaboration, or talking with other people and coming up with cool new ways you can mesh your work together into an exciting new project.